Uh, we're going to start, guys. We're going to start soon. So, guys, the reason we ended up moving to YouTube is because our TikTok platform it's very noisy. There's there are a lot of things happening there. I don't know. It comes with having that number of subscribers, and it makes sense. So many people are on TikTok per minute than we do have people on YouTube. I think at least as far as our feed recommendation goes. So I'm not sure if on YouTube it will end up being like that or what. I so hope not. So the biggest disadvantage about YouTube is that its live sessions are usually delayed. So whatever I'm saying, you're probably hearing it 2 seconds later or 3 seconds later, something like that. Whereas a TikTok session is actually as instant as possible. But that's not a train smash. We can always work around that. So I'm clicking here. I'm actually looking for this demarcation. The demarcation for the final exams was so nice that you basically know that statistics, as much as it is the easiest topic, it has the least marks for grade 11. Writing out of 150, we know that Euclid will give you 50 marks. We know that trig, that will give you 50 marks. Analytical, we know that will give you 30 marks. And stats will give you 20 marks. All right. So these are the things we know so far. These are the things we know that, okay, we need to put more focus on trig and Euclid because that's where our 100 marks are coming from. So with those things, it will be a long paper in terms of thinking because there are so many things you guys might have forgotten, but this is what the live session is for, right? I'm so lazy to share the live session with the people in our group. I told them what to do to attend the live. I hope that will be enough. That should be enough. I mean, like, yeah. Okay. So now with our session, I need us to start with trig. Now, another thing is that we're going to have limited space here, and I don't know what to say. Like, the space is very small. I want us to start with trig and do things like, okay, this is analytical geometry. I'm going to start by doing trig. After doing trig, I'll probably do analytical because I saw that most of you are suffering with analytical. As a matter of fact, let's start with analytical because it's easy. It's 30 marks. And then we'll do trig, right? So for analytical geometry, we know that here we are working with, let's put it here. We know that in analytical geometry, we are working with gradient. We know that we are working with distance. We know that we are working with midpoint. And these items have their unique formulas, right? You know that there's a formula you must apply for gradient, for distance, for midpoint, right? And then for midpoint, we know that there's that theory that says the tangent of theta is equal to the gradient. That's one of the things that we know so well. So now, those main factors that we have, we want to apply them here and see how we can work with them to actually answer these questions. We have this first one. Let me zoom in so that you can actually analyze it. So it says, in the diagram, coordinate P, it has X and Y. That's so that you can see it. And then we do see that coordinate P has X and Y as it appears. It says coordinate Q has -2 and 2. And it says coordinate R, we have 2 and 3. Okay, that's a mistake now. All right, because R is not 2 and 3. R is 3 and 4. So usually in these situations, whichever one you use, you have to stick with it, right? So that's the bad part of it, actually. I hate this. Okay. And then it says these are the vertices of triangle PQR. Triangle PQR. And then the line PR. Here's the line PR. This is why you actually need to check these things that they correspond. It passes through the origin, and then we see that at O, the equation of PQ is given as y is equals to. Now, do you see this equation? There is something wrong with this equation. I'll just highlight it. These are the things you're supposed to pick up. Okay, it says the equation of that, the thing of that equation. That's what you have there. It's as follows. And then it says the x-intercept of the line QP. S is the x-intercept of the line QP. And then we see that S is there. All right. So now we are going to say calculate the gradient of PR. And now it sends us to coordinate R. And it's so disappointing that R is like that. So let's do that. Let's find coordinate of R. Coordinate of R. Choose a red pen there. The gradient of R, you're going to do as follows. For you to find the gradient of PR, this is how I actually expect you to answer. It's much easier this way. I'm going to say y at P minus y at R all over x at P minus x at R. And with this situation, of you being told that R is this, and then here you're told that R is this. This is why it's important for you to eventually write the values of your coordinates. Like when you say this is your coordinate, work with, like, write it on the side. So that's what I'm going to do here. I'm going to say coordinates for R and coordinates for P. And I'm going to pick this coordinate to work with it. Since it clashes with this one, I have to pick one, right? Will you get penalized for choosing this? No, it's their fault that they gave us different coordinates. Okay, so I'm going to say this is 3 and 4. And then coordinates for P, I'll be choosing this one, right? And then here I have X and Y. So now in that case, for us to be able to end up finding this gradient, we need to have two coordinates here and there. But then because I don't have this coordinate, I cannot use it. So there is something that I need to consider here. Since I do not have this coordinate is found on the whole line here. And in this whole line, what I know about it, I know that it passes through the origin here, right? So since they only want the gradient of this line up until here, I know that the gradient of this line will be equal to the gradient of this line. Like I'm saying, the gradient of OR will be equal to the gradient of PO, this way, right? So since now I don't have the coordinate for P, I'm going to find the gradient of PR using the line OR instead of PR, right? So let me rewrite this here. It's crazy that I didn't see it. So I'm going to say gradient of PR must be equal to gradient of OR. My reason, the lines are collinear, this way. And then here I'm going to say gradient of OR is equals to y at O minus y at R all over x at O minus x at R. Then I write coordinates for R and coordinates for O. Coordinates for O, I have 0 and 0. How do I know? They said this is at the origin. At the origin, I know that x is 0 and y is 0. And then coordinates for R, we said we are choosing these ones. So I have 3 and 4. Then I make my substitutions here. I'm going to say my M at OR is equals to y at O, it's this one, which is 0, minus y at R, which is 4. And then I have x at O, which is 0, minus x at R, which is 3. My answer here now is negative 4 over negative 3. Therefore, being the gradient of OR is equal to positive 4 over 3. Bear in mind that my M, it's a small letter M. It's not a capital M. Right? So there was that 2 marks with those small errors there. The tricky part was this one here. That's, okay, I also need to make a conclusion. Therefore, the gradient of OR is equal to the gradient of PR, which makes the gradient of PR to be 4 over 3. I need to conclude with the gradient of PR, which is the answer that they wanted. There we go. All right. So now that they asked us gradient, most definitely they'll demand something different from us. They asked about the gradient of this line. Now, usually these questions, they carry over one concept to the next part. So now that we found the gradient of this line, let's see what they want. It says here, determine the equation of PR. There we go. Right. So for you to give me the equation of PR, you're going to start with the general equation of finding a straight line function, equation of a straight line. So you're going to say y is equals to mx plus c. This is the equation actually for analytical geometry. Then you're going to say your m is equals to 4 over 3. Why? Because you found the gradient of PR here. Right? You found that this gradient is 4 over 3. Therefore, in this situation, your m is 4 over 3. Now we need to find the c. To find the c, you're going to say substitute one of the coordinates, coordinated O and coordinated R. If you can manage, try to substitute coordinate of R instead of the intercept. Use coordinate that is not on an intercept, but if you don't have a choice, then you can use this one. But I'm saying always look for a coordinate that is not on the intercept. So I'm going to say I'm substituting coordinate R, which is 3 and 4, into the equation. Y is equals to, I have my m so far, which is 4 over 3x plus c. All right, I'm substituting this coordinate here, which means when I see y, I'm going to put 4 because y of r is 4. Multiplied by 4 over 3 into, when I see x, I'll put 3 plus c. Then what do I have? This cancels this. I have 4 being equals to 4 plus c. When I transpose things, my c will be equals to 4 minus 4, which is 0. Now, to answer their question, I know that my equation is equals to y is equals to this gradient removing the c. So 4 over 3x. But you can say plus 0, or you can write it without a plus 0. It's fine. The plus 0 doesn't do anything to it. Right? That's the equation of PR, right? Now, afterwards, they're saying to you now, determine the coordinates of P. And now look at this. They're telling you that this is 4 marks. Now, that's a sneaky way for them to ask you to find coordinates of P. Because usually when you have a coordinate, when you have an equation of this graph, the equation of this graph is y is equals to 4 over 3x. That's the equation of this graph. We found it here, right? Usually when you have an equation like this one here, you're just supposed to have one of these coordinates, substitute it here, and then solve for the other coordinate. But we don't have that luxury now. Let me write this properly because it's not neat. Four over 3x. This is the equation of this line. Now, what was I saying? I was saying that for us to find these coordinates here, they need to give you one of these coordinates. It can be an x, it can be a y, but when you substitute one of these coordinates, in which would be given here, right? When you substitute one of these coordinates here, what's supposed to happen is that you'll sub it and then you'll be able to find the other coordinate that is missing from the equation. But then now, when they give us 4 marks for us to find coordinates of P, clearly, there must be something else that can help us, since here I'm missing both coordinates. Right? So, what happens now? Going to say, I need the equation of this line. Do I even have the equation of this line? The line PQ. Let's check the statement. The statement says you are given the equation of the line PQ. And then they're saying it's this one here. You see that? So which means here, this story here, it has an equation that says y is equals to 6x plus 14. Now, things are looking good now because I'm having an equation of this line as I wrote it here, and I'm having the equation of this line as I wrote it here, which means now, basically, I can understand that these two equations, this line and this line, when it comes to this point, at this point, sorry, they're the same. The x value here and the y value will be the same, whether I'm using this equation or whether I'm using this equation. What does this mean? It means these two equations at the point of P, they are the same. They give you the same output. They have the same input. Like at this point exactly, they are the same. All right. So I'm putting that here. Let's choose a different color because there's a whole lot of mess here. Boom, yeah. So put that in writing. This equation and this equation at this point, they are the same. So in writing, that is 6x plus 14 is equals to 4 over 3x. And then usually what happens in this situation? Number one, I want to remove the denominators. They're troubling me. I can do that just now. So I'll say this part here, the 4 over 3x, I'm multiplying it with a numerator 3. This way. Which means the other parts also have to be affected the same way. So I have 6x, I have 14. So the 6x and the 14, they have to be affected by the same thing that affected 4 over 3 here, right? So I'll multiply this by 3. I'll multiply this by 3. Now this removes that. And then on this part, I'm having 6 multiplied by 3, which is 18x, plus 14 multiplied by 3. 14 multiplied by 3, how much is that? So lazy to even calculate. I know that I have 14 by 2 being 28. 14 times 3, let's see. 42. This is equals to 4x. All right. So now I'll be solving for x. I'll just have to transpose the 4 to the other side. So I have 18x minus 4x is equals to sending 42 to the other side. Negative 42. All right. What do I have? Let's cut it here. This will be enough. I have 18 minus 4, that is 14. 14x is equals to negative 42. Then you use a calculator, you say 42 divided by 14, of course that's 3. Your x is equals to, oh, sorry, I'm skipping steps. Shouldn't do that. Shouldn't be skipping steps. I'm saying this part, for me to remove the 14, I have to divide by the 14. And same thing applies here, such that the 14 removes the 14, and I'll be left with x being equals to negative 3. Does it make sense for x to be negative 3? Yes. Because we are on the left side of the Cartesian plane, it makes sense for x to be negative 3. Bear in mind, we are not done. That's part 1 of finding coordinates of P. Right? That's part 1 of it. So I found the x value of it, and here it is. And then now I need to find the y value of it. So the y value, I'll just put it here. Let's provide some space here. Said that when we are on a live session, I cannot pause this thing and erase. You just have to wait and watch me erase here. So now I have to use one of these equations. Remember, we said at this point, this equation and this equation are the same. So I have to use one of these equations to find the value of y, since now I found x. My x is negative 3. I can just put x as negative 3 here. I can put x as negative 3 here. Whichever way, it's fine. All right. So I'll use this equation. I'm substituting x as how much? It's negative 3. And what happens? The 3 denominator cancels 3 whole number. I have negative and positive and negative giving me negative. And then I have a 4 here. There we go. Does it make sense for our y to be negative 4? Yes. Because we are below the x-axis, our y values are negative. So which means here being at negative 4, it pretty much makes sense. And then the final answer. Remember what they asked you. answer what they asked you. My x is how much? Is -3. My y is -4. Not too terrible, is it? I so hope not. I so hope not. We have the last question here, which is determining the coordinates of S. Which is so possible. Because what did they say about S? Here's S, by the way. They said S is the x-intercept of this equation. So which means I need to find, of this function, right? So on this function, I need to take its equation and make, in this S, allow my y value to be 0 because on the x-intercept, y is 0. Let's do that. Let me write the equation first. 6x plus 14. So 3.4 y is equals to 6x plus 14. And then I substitute what is true here. I know that I have my y value because we are on the x-intercept. My y value is equals to 0. My x value is equals to, in fact, it's what I'm looking for. So 6x plus 14. Right? And then afterwards we solve for this. I'm going to have 14 going to the other side. So I have -14 is equals to 6x. What do we do here to make x the subject of the formula? Divide by 6. Divide by 6. This cancels that. I'm left with x being equals to negative. So 14 divided by 6, that is 7/3. There we go. Not complaining. This is a nice way to do analytical geometry or to start analytical geometry. I hope it's of any use. Any questions here? Hello guys, those who are typing, hello. I hope you're well. Any questions for us here? $42. Oh, when you type 42, that's when you are answering 3 times 14, I think. Yes, 3 times 14. Thank you. How do we know QP is equals to PR? Oh, when we said QP is equals to QR, right? Hello. When we said QP is equals to QR, we are not saying the entire thing. We are saying only at this point. This is the point of intersection. On the point of intersection, the two lines that are intersecting, their equations will be the same. That's how the rule goes. Like on the point of intersection, the two functions, their equations will be the same there on the point of intersection. I hope that answers you. Any other questions before we move on? Yeah, sorted, right? All right. Thank you, Kauhelo. I see your text now. So the next thing we have in line, this one, it's making the grade 12s cry. We're doing it during the holidays. It's a serious situation. Well, this is the last question of analytical. That's very, very nice of them. The previous one was 10 marks. This one is 20 marks, which makes sense. Analytical is 30 marks. So what do we have here? Let me read the statement. The statement says, in the diagram, ABC is drawn with vertices A. Remember, you need to check these things. A is -7 and 0. B is 3 and 8. P is the midpoint of, it's very important. Like, let me show you. it's very important that we highlight what they're saying here, because afterwards we have to consider the implication of it, that this is what they're saying, and after they said that, this is what that implies, right? So P is the midpoint of the line AB, right? So we see that here is A, here is B, and then the implication of P being the midpoint, it means the distance from P to B and the distance from P to A, it's the same, and we can see with the markings there, right? Very imperative for us to note that. And then they're saying that Q is a point on AC. So bear in mind, they're saying Q is a point on AC. They never said Q is a midpoint of AC. They just said Q is a point on AC. Very important also. Then they're saying AQC is a line on the x-axis. So AQC is a line that is on the x-axis. They're saying E has coordinates of -1/2 and 2, right? And then and they're saying E is a point on PQ. They never said it's the midpoint. And then PQ is parallel to BC. PQ parallel to BC. Now let's get to the question. I think I've analyzed this information. I'm happy with it. So let's get to the questions. The first question says, calculate the coordinates of P. Now, I'm sure by now you all see that on this one, on this question that has passed, we're busy working with gradient, equation, coordinates, basically. Like, that's just that. They didn't demand the midpoint thing from us, right? So now in this situation, the first question they ask us is coordinates of P, in which P, it is the midpoint of the line AB, right? So we want to go through with that. Let's see how can we answer it. Midpoint, we have to use the midpoint formula for us to find those coordinates. So I'm going to say now, let's use a red color or blue. We haven't used blue. Finding coordinates of the midpoint, the formula says this is the midpoint of A and B. All right. So which means for me to find x of the midpoint, I must take x of A, add it with x of B, then divide by 2. For me to find y of the midpoints, I need to take y of A, add it to y of B, then divide by 2. All right, so let's find them. You're going to write your coordinates here. Remember, that's what I always said. Coordinates of A is -7 and 0. Coordinates of B is there, 3 and 8. Substitutions. X at A, that's -7. Plus x at B, that's 3 over 2. Y at A, that is 0. Y at B, that is 8 over 2. So coordinates of P, we have, what is this, -7. Oops. I want to say this, I want to point at it. This is -7 plus 3. -7 plus 3 is how much? That's -4. And this 0 plus 8, that is 8 over 2. Therefore, coordinates of P are equals to -4 over 2 is -2. 8 over 2, that is 4. Boom. This 10 marks that they gave you here, oh, we passed the 10 marks. We collected the 10 marks. Okay. This 20 marks that they gave you here, I expect you to kill it. No excuses. Here, I expect you to kill this one. We can move on, right? Let me check the comments. I'm using like 2 devices. One to read if I have a comment, and the other one to zoom. Thank you, Kahelo. Yes, that's the answer. Right. So let's move on to the next one. It wants the gradient of AB. Now we've been doing the gradient long enough that it shouldn't give us a problem from here. All right. So let's say now the question says gradient of AB. That will be equals to y at A minus y at B all over x at A minus x at B. Remember, the formula does not have marks. It's the substitution part that has marks. Right. Coordinates for A, we said we have -7 and 0. Coordinates for B, we said we have 3 and 8. So, subs into the equation. Y at A is 0. Y at B, that is 8. X at A, -7. X at B, that is 3. The numerator becomes -8. The denominator becomes -10. Simplifying, you can just take this entire answer, put it on a calculator and see how much you get, right? So the answer, we know that it's positive because we have numerator negative and denominator negative. And then highest common factor, is it? Yes, highest common factor for 8 and 10, that is 2. If I divide 8 by 2, I get 4. 10 by 2, I get 5. There we go. Another question that was doable, a throwaway here. So 2 marks collected, 2 marks collected here. And it says the size of theta. We spoke about this in the beginning of this live session. The size of theta. The size of theta is the angle measured from the x-axis up until where the terminal is. No matter where the terminal is, that's how it is. You measure from the x-axis and then you move anti-clockwise to where the terminal is. So now, let's use that information we have to find 413. So 4.1.3, we know that the tangent of theta is equals to m, right? And then so now in this case, x at b is what? X at b is 3. Yeah, I did say x at b is 3. I see your comment, Nepawe. I see your comment. Yeah, I did say x at b is 3. Did I make a mistake elsewhere? I don't see it. All right, let me move on then. I really don't see where did I make a mistake, Nepawe. I did use x at b as 3. So now, as I was saying here, let me switch on the lights because actually I'm not using the lights for the study table. So now to find theta, I need to take the tangent to the other side. But I need to know what m is. What is m? M is the gradient of this line AB. Okay, let me reduce brightness a bit. Smoother now. Yeah. But I can see that it doesn't affect the brightness on my life. So that's good. So yeah. Now, here we are saying that we transpose tangent to the other side, but we need to find m. M is the gradient of this line that we're working with, AB. And we already found the gradient of the line AB, which is 4/5. So I do my writings here. Let me use a red pen because we have the same color too much now. I'm going to say tan theta is equals to this gradient of 4/5. Right? Transpose the tangent to another side. We call it transposing, but in math, it's not really transposing, but it's fine as long as you understand. Then you use your calculator. On your calculator, you say the shift tangent of 4/5. and then you get 36,66. Make sure that your calculator is in the right program. Thank you, Cowhello. Right? So make sure that your calculator is in the right mode for you to get this answer here. And then there we go. 36,66 degrees there. Right? There is this question whereby this thing ends up giving you a negative. When it gives you a negative, just add 180 on it and then take the answer that you get. Right? So there we go. And afterwards, question 4.2 now. Now we are here. 4.2, it wants you to give them the equation of BC in the form of y is equals to mx plus c. So we collected marks here. Oops. And now we need to collect marks here. 5 marks. Bear in mind, they won't just put those 5 marks there for no reason. There must be something. They said they want the coordinates of the line BC. Let's go find BC. Here is BC. BC. Now, do you see how wicked the examiner is? Here's BC. Bear in mind, in BC, you don't have 2 coordinates. You only have 1 coordinate, which is B. So which means for you to be able to find the equation of this line and start by finding gradient, it will be tough because for you to calculate gradient, you actually need 2 coordinates, right? So if you don't have those 2 coordinates, then it's not working out for you. But what do we know about this thing? What we know is that, let me choose a smaller highlighter there. What we know is that this line, the way it moves from here up until there, it's parallel to this line here. I mean, it's given to us by these symbols, right? So these 2 lines are parallel. Now, when 2 lines are parallel, what conclusion can we make about them? The conclusion is that they carry the same gradient. Now, let me write that down. We start there. That's our starting point. We put it here. I'm going to say gradient of PQ is equals to gradient of BC. It needs a reason. You can't just say things like that. Then afterwards, I'm going to say because PQ is parallel to BC. Boom. Do we see that? Then afterwards, we continue with thinking. We continue thinking. If I can't find the gradient of BC using BC, can I find the gradient of PQ then? Because if I can find the gradient of PQ, then I can find the gradient of BC. Now, in this part, I made a mistake, and this we call it a planning mistake, because it's not a mistake in values. It's a mistake in how I go through the paper. Every time you go through the paper, any small detail you can find about the paper, about the diagram, you put it on the diagram. So here I had coordinates of P calculated at some point somewhere. I forgot where. Let me see. Here. I had coordinates of P. What I had to do, I was supposed to come back here and place those coordinates right here. Wait. Is this what I wrote here? I was supposed to simplify this. Oh, I did here. Oh, I was surprised. Okay, those coordinates is -2 and 4. So let me put them here. -2 and 4. Those are coordinates of P. Now, you see how it unfolds now. On the line PQ, I have coordinates of P, I have coordinates of E. That's all I need. That's all we need to find the gradient. Come back here. I'm going to say the gradient of PQ is equals to the gradient of PE. Reason, these lines are collinear. Right? So the line PE will have the same gradient as the line PQ. Why? Because they're on the same line PQ. Right? So if lines go into the same direction, they're on the same line, the gradients will be the same. Now, let's find the gradient of PE. It's equals to y at P minus y at E all over x at P minus x at E. Right coordinates. Coordinates of P, I have negative 2 and 4. Coordinates of E, I have negative 1 over 2 and 2. Then we make our substitutions. Y at P is 4 minus y at E is 2. X at P is negative 2 minus x at E. X at E is negative 1 over 2. All right, so solving things out, 4 minus 2, that is 2. And then here I have negative 2. I have minus minus, which is now plus 1 over 2. Right, so what I would advise, put this entire thing on the calculator, otherwise you'll run around throughout and it's going to waste your time. So you have 2 divided by negative 2 plus 1 over 2. The answer, negative 4 over 3. There we go. Found the gradient of PE. And now I can say, therefore, the gradient of PE is equal to the gradient of PQ. I said that, right? I already said that. I already said the gradient of PE is equal to the gradient of PQ, right? And then afterwards, I'm going to say the gradient of PQ is equal to the gradient of BC, which means now the gradient of BC is negative 4 over 3. I said that also. Gradient of PQ is equal to gradient of BC. So which means now gradient of BC is 4 over 3, negative 4 over 3. Now that I have the gradient, I can use the gradient now to find the equation of this line that they wanted me to find here. And how do we do that? We substitute one coordinate there into that thing. Let's do it. I'm going to say in line BC, I want to sub coordinate B into the half equation. The half equation is y is equals to negative 4 over 3x plus c. Right? Then make those substitutions. My y is 8. My x is 3 plus c. Whole number cancels denominator. I have 8 is equals to negative 4 plus c. Send negative 4 to the other side. We are having 8 plus 4 is equals to c. Therefore, c is equals to 12. Now, the final answer, the equation is y is equals to negative 4 over 3x plus 12. There we go. How beautiful is that? It's a bit messy now that when we do it here instead of a paper, the actual paper, but also there is less traffic here. Next one, right? 4.3. 4.3 says calculate the length of AC. So this is very tricky of the examiner. So much because there are multiple ways he could have asked this question properly, but he decided not to. And that's the problem I have with him here. Very much. Okay, let's see how we do. He's saying that find the length of AC. The length of AC, it needs the distance formula. If possible, if necessary, right? So let me highlight AC with a different color. There we go. For AC, basically, we need a coordinate here in which we have, check. Then we need a coordinate here in which you don't have, bad. So what happens now? what happens is that I need to consider that this coordinate C is found on the line BC, and on the line BC I have an equation, the equation of the line BC. And where did I get that? They just asked me to find that on the previous question. Here is it, right? So I have an equation. So for you have to direct the marker for line BC, right? Show him where are you focusing now. Don't just put things there randomly. For line BC, we know that this is the equation. Which one? This one, the one that we just found previously. For line BC, y is equals to negative 4 over 3x plus 12. So when that is the case, I already know that C, it's on the x-intercept. What do I know about the x-intercept? I know that the x-intercept y is 0. So let y be 0. So this is the x-intercept. Y is equal to negative 4 over 3x plus 12. I'm transposing the negative 4 over 3 to the other side, so it becomes positive. It's equal to 12. Now what do? I want to do away with the denominators. Remove denominator. Multiply this by whole number 3. Multiply this by whole number 3. So denominator 3 cancels whole number 3. I'm being left now with the 4 and the x. This is equals to 12 by 3, which is 36. Yes, 36. Just use a calculator, don't be like me. I make a lot of mistakes due to not using a calculator. I'll divide this by 4. I'll divide this by 4. This cancels there. It means my x will be equals to 18, not 18, sorry, 9. Because 9 times 2 is 18. 18 times 2 is 36. Perfect. Again, use a calculator. I make a lot of mistakes by trying to calculate things with my head. Thank you, Giza. Thank you a lot, Giza. So I found the x value here, which will now make things easier. I know that x here is 9. I know that x here is negative 7. Now, trust me, the examiner will not expect you to find, using the distance formula, something so obvious as this one. This you can solve by inspection. What are we saying now? We are saying the distance from here to there, it's 7 units. It's not negative 7 units. There's no negative distance, right? So the distance from the origin here up until where A is, that's 7 units. The distance from the origin to where, what is this? C, where C is, that is 9 units, right? So which means if this one it's 9 units away, let me use the pointer here. If C is 9 units away from the origin and A is 7 units away from the origin, then counting both their distance, the 7 units away, the 9 units away and the 7 units away, it makes these two people to be 16 units away. Write that down. Therefore, AC is equals to 16 units. Do we all see that? And then afterwards, it wants the area of a trapezium. I'm so lazy. I'm so lazy because I know what they want here. It's unnecessary and wrong. Not wrong. It's unnecessary and long. Okay, let me just give you the idea. In fact, I'll just do it. Let me find space. They want us to find, okay, the area of the trapezium, right? P, B, C, Q. Here it is, P, B, C, Q. Now, I'll have to release these things to do that. And I don't want to do that. Here's what I'm thinking. Here's what I want to say, right? for us to be able, this is a dirty way for the examiner to do it, for us to be able to find the area of this trapezium here, we need the area of the big triangle and then subtract the area of the small triangle. Are we good? Let's start with area of a triangle. Triangle AQP. In triangle, what? The area rule says area is equals to half adjacent sides and the sine of the included angle. Let's go there and see what's happening there. Adjacent sides, we have this side and we have this side. Then we have the included angle here, 36.66. So this side it's AP, half of AP, multiplied by half of AQ, multiplied by AQ, with the sine of the included angle. The included angle is A. And then from here, we want to, oh, I'm so tired. From here, we want to find the values of those things that we are talking about. I need to find the distance AB. Not AB, what is this? AP from A up until P, right? So the distance for that, I just need to calculate it. It's a lot of work. Okay, let's do it though. Distance of AP is equals to x at A minus x at P squared plus y at A minus y at P all squared. There we go. Then you write down coordinates. Coordinates for A. Coordinates for A here we have -7 and 0. And coordinates for P, I keep on forgetting this, -2 and 4. Right. So now that we found, okay, now we substitute distance of AP is equals to x at A, which is -7, minus x at P, which is -2, square that, y at A, which is 0, minus y at P, which is 4, square. Then you just put the entire thing on a calculator. This is root 41. Right? There we go. And then afterwards, we have to find, where's root 41? Root 41 is this part here. Do we see it? That's root 41. Then I want the distance from here to there. I already said that that is 7 units. And I'm going to say, and the distance of AQ. Do we see that? So now I have this distance from here to there. I have this distance from here to there. Now I can just find the area of this small triangle. The area of that triangle, here we are, I was just there. Let's make substitution. Area is equals to half AP. AP, we said it's how much? Root 41. Half AP, and the other adjacent side, which is AQ, we said AQ is 7 units. And the sine of how much? We go back to the diagram, 36.66. Then put everything on a calculator. how much are we getting? 38.66. Let me check. Wait. Arctangent of 4/5. Yes, 38.66. Thank you. Thank you, Tapiwa. Where was I? Yeah, also here I need to change that. Yeah. So I was just checking this on my calculator. 0.5 multiplied by root 41. And then I have 7 times the sine of 38.66. This gives me a solid 14. Nice. Right? The area of the small triangle, that's 14. 14 square units. So afterwards, after finding the area of the small triangle here, I need to find the area of the bigger triangle. Right? And then so I'll do that just here. There's no space here. Where should I write it? I'll write it here. For the bigger triangle, which is triangle ABC, for triangle ABC, for me to find the area, I need to say half adjacent sides. What are my adjacent sides? My adjacent sides are these ones, AB and AC. Right? Put that down. Half times AB times AC multiplied by the sine of the included angle. The included angle in this situation, it's A. The sine of A. Right? Then I need to find Drenugu, the formula has a sine A because, yes, as Tapi was saying, it is the sine rule from trig into these. Yes, yes. And then Kauhelo is saying, is it going to be meter squared or just 14? It's going to be squared meters, the way I wrote it. There's no meters, in fact. We're working with units. So it's going to be square units, not meter squared, because they never gave us SI units. So we just work with units. All right, so moving on. My side AB, this is so doable. AB, I already have the length of AP. So AB is equal to 2 times AP. I must not rush, I must show you. The length AB, it is AP and PB. But since AP and PB are the same, I'm going to say the length of AB is equal to 2 times AP. Right? So AB is equal to 2 AP. And I have AP from this part here. AP is root 41, as we said. Right? So I'm going to say, therefore, AB is equal to 2 times root 41. And I'll keep it there. Right? So I don't have to work with a lot of decimals there. Then I'm looking for the distance of AC. I think we found AC. There's a question that said that, yes, here we are. This question here said we must find AC. And then we found it where? We found it here. We said AC is 16 units. Right? So I'm going to say AC is 16 units. So now we can work. Area of this thing, area is equals to 1 over 2 times AB. My AB, we said it's what? It's 2 root 41 multiplied by AC, which is 16 units, multiplied by the sine of A. And sine of A, I've been making mistakes, but now I want. That is 38.66 degrees. All right. Then when we put that on a calculator, we have 64. Oh, this is looking good. It's looking right. Square units, 64 square units, right? So now, why were we calculating areas? For us to find the area of this, what is the shape? Trapezium. For us to find the area of this trapezium, we had to consider that we can take the shape of the entire triangle, right? Remove the area of this smaller triangle. Then we'll be left with the area of this bottom part here, right? So the area of the big part, which is 64, subtract area of the smaller triangle, gives us area of the trapezium. Now we put that in writing. That's why it was 6 marks. Area of trapezium is equals to 64 minus, is it 16? How much was the triangle? I remember I found it somewhere. Yo, I need to erase after writing because it's messing me up. Boom, boom, boom. It's 16. Oh my God. No, it's 14. Yes, perfect. Area of that small thing, it's 14, right? So I subtract 14 here. Thank you, Tapiwa. Subtract 14. This is going to be equals to 50. Yes, 50. There we go. I don't think this is too terrible. The thing is I need to erase every time after writing because it's messing me up. But erasing also will be a huge problem because I need my answers going forward, especially on analytical. Oh, to get the trapezium, we said, right, Paolo? We said that for us to find the area of this trapezium, right, we have to take the area of the bigger triangle, right, and then subtract the area of the smaller triangle, which is this one here, right? And then if we take the area of the bigger triangle and subtract the smaller triangle, then we get the area of this shape that is left here, which is the trapezium. Hope that makes sense. All right, let me take off the jacket, it's hot. Now I want us to move on to, oh, we're still going to trig. Okay, let's go to trig. Please hold on there for like 30 seconds. I'm coming back. Okay, let's do it. So here, let's erase this so that we can do the proper trick. There we go. So for this part, right, we have the following things. We are supposed to be able to solve for this on a diagram as it appears. All right. So yeah, guys, the live session will end at 10. We still have time. We have like 2 hours left. 2 hours, 13 minutes. So now in this situation, they want you to find this story here. But this story here, it's dependent on you understanding that this is trick on a Cartesian plane. Now, how do those things happen? I'll erase here because I actually need the space. There we go. That's all I need. Okay. The statement says they want you to, of course, they haven't said that in words, but they want you to draw a diagram. And in that diagram, you must consider this part here, and you must consider this part here. These two things should be able to help you build a terminal. And once you build a terminal, then you solve for the missing component, and then you answer this question here. This is actually the question. This is the structure, right? So now with those, let's proceed forward. Our situation is that we need to construct the Cartesian plane. I'll put a Cartesian plane way above here. Doesn't even need to be perfect, just the Cartesian plane. Do you need to draw the diagram on the test? Yes, you need to draw the Cartesian plane. It needs to be correct. There are marks for it. All right. So afterwards, we have this statement here, whereby they're saying you have this, right? We need to solve this out and see what does it give us. All right. So I'm going to write it down. This is -3, the tangent of beta minus √5. This is equals to 0. So what happens is that I'm going to take this, send it to the other side. Why? Because I'm trying to isolate everything from beta in a way. Not really everything, but yeah, you'll see. So then I have -3 tan beta is equals to positive √5. Now, do you see what happens there? Now I need to remove the -3. For me to remove the -3, I'll divide this side by -3. What I do on the left, I must also do on the right. This cancels that. And then I'm left with what? The tangent of beta giving me -√5/3. Now, this is a P statement. This is a statement that helps me fill in this diagram that I see here. Right? So this statement is saying I must work in any situation. Do you still remember cast? Cast. Yeah. I must work in a statement whereby the tangent is negative. That's the main thing. I must work in a situation whereby the tangent is negative. And those situations, they can either be, mind you, we wrote this casting, right? So in this casting, what we know is that the tangent is negative on this quadrant and on this quadrant. All right. So that being like that, now I need to assume, thank you, Zuma, quadrant 2 and 4. Now I need to assume that this terminal might be in one of these items. That's a calculated guess now. Afterwards, I continue forward to find a statement that helps me find a specific quadrant whereby these things will be true. So done with this, check. Now we go to the statement here. This statement says this terminal, it's actually on the quadrant whereby the sign of beta is less than 0, whereby I'm saying the sign is negative. It's saying in all the two options that I have here, in these two options, this one and this one, I must consider a quadrant whereby the sign is negative there. You see how we break it down, right? So I'm coming back here and I look at these two quadrants. Here the sign is positive, here the sign is negative. It means now my terminal should be in this quadrant where the sign is negative. That's based on this statement. Check. All right. Then afterwards, I create a triangle. That triangle should always rest on the x-axis. Here's the x-axis, right? And then this triangle now must be filled in with details. And then on this triangle, this terminal was measured this way, such that this is my beta. My beta is not inside here. My beta is the angle I measured all the way up until here with this terminal. You see? Now we are getting deep into maths now. So now in this situation afterwards, I'm coming back to which statement? This one. But I don't want exactly the statement. I want the one that is corrected, which is this one here. Let's choose a different color because it's very important. This statement here. See the statement? It's very important. This statement says, I have a negative 5 over 3. The negative belongs to any part. Don't just associate 5 with the top value. What I need to understand is that according to the phrase SOHCAHTOA, you see now we are pulling out from every angle. What I understand is that from this phrase, whenever I have the tangent compares the opposite over the adjacent. What is this? This is y and x. Opposite is represented with y, adjacent is represented with x. Now, I use this small information now. I piece it to this statement here. This is x over y, right? And then afterwards, I go back to the diagram, this diagram here. On this diagram, one of these things has to be negative, either the x value or the y value, one of the two. But which one can be negative? Obviously, because we are on the positive side of the x, we are on the right side of the x-axis. It's not x that is positive, rather it's the y value, because y here is negative. That's a negative y value there. So which means in this two, this negative belongs to the y, right? So I'm saying now I have I'm saying now that I have root 5 over negative 3. That's the only way it makes sense, because my y is negative and my x is positive, right? I need that information. It's very important. So I take that and then I complete the missing part. Let me write these items here. I'm going to come back here now and choose this pen. Yeah. On my x values, I'm going to say I have root 5. Check. And then on my y values, I'm going to say I have negative 3. Check. Now on this right angle triangle, what's missing? It's r, right? You need to draw this triangle. Afterwards, you fill it in with details like this because it has marks. So moving on with it, I'm going to use Pythag now because I need to find what the value of r. So we come back here, we're going to say r squared is equals to x squared plus y squared. Every time you use Pythag, you acknowledge Pythag. Every time, whether you are doing in algebra or sequences or whatever, you use Pythag, you acknowledge Pythag. That one is universal. All right, so now my r squared will be equals to, I substitute, what is my x? Here's my x, negative 3. What am I saying? My x, it's this part here. That's my x. That's root 5. I also said it here. Square that. And my y is this part, -3. Square that. So my r squared is equals to, when you square something that's under a root, the root falls off. You're left with the number. When you square this, you get a positive 9. Right? So my r squared is equals to 5 plus 9, which is 14. And I'm going to say, therefore, r is equals to plus minus the square root of 14. Then I make a conclusion because I know something. I'm going to say, therefore, r is equals to root 14, and r is not equals to negative root 14, because I know that my r is always positive. All right, then I can remove this. I've used the phrase, done with it. I have my r now. Now I can get to the part of solving for the question, because of actually, this is the question. This was interpretation, but mind you, interpretation has marks, right? I know this is 5 marks and it looks like a whole book that I'm writing, but it actually supposed to be like that. Tangent is y over opposite. Thank you. What am I doing? Oh, yes, tangent is y over opposite. So I'm supposed to have, oops. Tangent is y over adjacent, not y over opposite. I'm even making mistakes still. Oh, yeah, that is the case. Boom, boom. This is y over x this way, right? Which makes this value here to be, my y is root 5 and it's negative, my x is 3, which means here I have root 5 have my y, have my x. Oh, I think it's still good. Just need to remove this part because it's positive, and then put in the negative here. Yeah, I think it's still good. Thank you, Renoko. Thank you, Renoko. Yes. Then afterwards, I need to come and answer the question here. The question says the square sign of beta, this is equals to the square cosine of beta. And then I need to sort this out. So again, using the phrase, maybe I shouldn't have deleted it. So Katoa, right? When I need the sign, I need opposite, which is y, over the hypotenuse, which is r, right? So I'm going to say y over r here squared minus the cosine. The cosine is adjacent. Adjacent is x over the hypotenuse, which is r, minus x over r squared. Does this step have marks? No, it doesn't. The step that has marks, it's the substitution step. Make sure you don't mess up the substitution step. Substitution alone, substitute without simplifying, right? No, I won't post this video on the channel later. I won't, right? So substituting this thing now, I'm going to say my y, where is the y value? The y value is root 5, negative root 5, so to say, over my r. My r is how much? My r is root 14. We square this, minus my x value. My x value is 3 over my r value, which is root 14. This way. All right, then simplifying this, you can just put that on a calculator. Here we are having negative root 5 over root 14. square the entire thing, we get 5 over 14 minus 3 over root 14, that is 9 over 14. And then the answer we'll be getting here will be, wait, is this 9 over 14? Let me check. Square there. Yes, it's 9 over 14. And afterwards, I have 5 minus 9, that is negative 4 over 14, right? Then afterwards, we can simplify that. When we simplify this, we are going to get negative 2 over 7. This way. It was a twist and turmoil. I don't know how I missed the y over x and made it x over y. Mistakes, guys. So we're good here, right? We can move on. We can move on. Don't forget, the diagram has marks. You need to write the diagram. Okay, to the next part. On the next part, I have 5.2, which says if cos 49. Oh, I remember this one. It says if cos 49 is equals to k, right? Determine the values of the following in terms of k. Now, again, this is another situation that has a diagram, even though it might not look like it, but it has a diagram. You're going to put this on a Cartesian plane. We're done here. Let's use a bigger eraser. Let's use the space here. So to do this one of cos 49, this is a p statement that we need to analyze, put it on the diagram. Then we write things in terms of k. So we put on a triangle here. And then we have 49. They're saying cos 49 degrees is equals to k. You write this k as a fraction this way, right? And then what does the cosine represent? Using the phrase again, SOHCAHTOA, we know that the cosine is adjacent over hypotenuse, right? This is adjacent over hypotenuse, right? It means our hypotenuse is 1, our adjacent is k. And now we are looking for y. You need to solve for y now so that you'll be able to answer these questions. You're going to say, oops, mistake. You're going to say here that your r squared is equals to x squared plus y squared Pythag. Remember, every time you use Pythag, you acknowledge Pythag. And then what do we have? Where there is r, we'll put 1 squared is equals to, where there is x, we'll put k squared plus y squared. Then we want to make y the subject of the formula. 1 squared is the same as 1, and then I'll transpose k to the other side. That'll be minus k squared. This is equals to y squared, right? Then I put a square root on both sides, right? So I'm going to have y being equals to plus minus the square root of 1 minus k squared, right? And then afterwards, it asks me, which y am I choosing? Y is equals to positive 1 minus k squared, or am I choosing y is equals to negative thing, right? Because I have two solutions, bear in mind, I have two solutions. Now, how do I know which one to choose? This was in the form of like As you see here, they didn't give us this thing like they did on the previous question. Right? So now here on my triangle, I'm going to choose the one with a positive value because we didn't have these restrictions here. And on my triangle, this is always positive on the upside. Right? So now we do that. Going to say my y will be the positive value here. And my y will not be the negative value. There we go. And then afterwards, now that I have these things, let's put annotations here. Now that I have the y value, I have the r value, and I have the x value, I'm going to use those things to actually find all the items that I need. All right. So let's see how things will work out. This is going to give me the following. They want the sine of 131. The sine of 131 now, it needs me to consider a few things. Hello. No, this is not the part where we use special angles because 49 degrees, it's not a special angle. 45 is a special angle, but not 49. So here, since we have the following, now we have to take this item and rewrite it either by reduction or by this thing. What is this? Cofunction. Yes, cofunction. And then we have to remember when do we use cofunctions and when do we use reductions, right? So whenever we have a Cartesian plane this way, this is 270, this is 0 and 360. This is 180, right? Whenever we have a statement that is closer to the 90 degrees, we cofunction it. Whenever we have a statement that is closer to the 180 degrees, we reduce it. Usually we work like that. And now here I have 131. Now when I check my calculator, I see that 139, I can rewrite this as the sine of 180 degrees minus 49 degrees. And it's very interesting, but it's important to me that I write it in terms of 49 because why? I had a statement here that was working with the 41, and I drew a diagram with that statement that uses a 41. Right? So when things are like that now, I just want to employ those things. So how do things go forward? I'm going to say now, in my doing, I want to reduce this. Reduce. Right? When I reduce this item, I want to consider if whatever that I'm using in this quadrant, is it negative or positive, right? So this item here, it's the sine of 180 degrees minus 149. And I'm like, the sine of this thing in this quadrant, is it negative or positive? Obviously, it's positive. It's the positive sine, 49 degrees, right? And then rewriting that as the sine of thing, this compares y over r. And then since I have my y value here and my r value here, I just substitute that. The sine of 49 degrees is equals to y, which is the square root of 1 minus k squared over 1. And this will give me the sine of 49. Let me write it down there. This will give me the sine of 49 degrees to be equals to 1 minus k squared. There we go. Any questions here? Any questions? Hope we are all sorted. All right. No questions, it means we are moving on. Then afterwards, the next question wants me to find the following items. An item that says 1 minus. Now, this is a very interesting question because this is what I want to do to this question. Let's underline and put it here. Here's what I want to do to this question. Like it should trigger something in you once you see a question like this one. There's an identity that says, I'm going to use variables. The square cosine of A plus the square sine of A is equals to 1. Right? And then what does this identity do afterwards? It says I can rewrite this thing in any way. Right? Let's say I want to take the cosine and send it to the other side. What happens to it? I'll be left with the square sine here and say it equals to 1. Cosine to the other side becomes negative of A. Now tell me that this doesn't look like that. I mean, it's as plain as day. This is the same thing. Right? So now what are we going to do? How are we going to use that? I'm going to rewrite this in terms of this. But now where I see A, I put 41. All right. So I'm going to say, let's put this here. I'm going to say the square sine of 41 degrees is equals to 1 minus the square cosine of 41 degrees. And then afterwards, I'm looking at 41 now. 41 is such an interesting angle. I can work with it. So, okay. What I want to do now is to carry things over from here because I didn't want to work with this binomial over here. I want to work with this monomial. So instead of using this entire binomial, I'm going to use a monomial. I'm carrying this monomial downwards now. And I want to write it in a way that I won't have problems with it. The sine of 41 all squared. All right. And then afterwards, when I have this, I have to bear in mind that the question didn't come to me in terms of 41. The question came to me in terms of 49. But then, what is the relationship between 41 and 49? The relationship is that if I add 1 and this, it gives me 0, carry 1. Here, plus the carried 1, I get a 90. Now, when I add an angle with another one to get a 90, of course, here we are using cofunctions. Right. So now, I'm going to say the cofunction of this thing, the cofunction of a sine, it's a cosine, and the complementary angle of 41, it's 49 degrees. Boom. Keep that squared outside. All right. Then afterwards, we go to the phrase of SOHCAHTOA. The phrase says, if I'm using the cosine, I must take x and put it over r. Then we come back here, we do the same thing. Here I'm going to take x and put it over r. Remember, this is being squared. Right. And then this is equals to, I go and find whatever x is. In our situation, x is k. So I'll put that here. I think our R is 1. Yes. And then we square that. When you square this, you get k squared. This is our final answer. Now, would you look at that? So beautiful, isn't it? I usually take long to go around things, but it's for the sake of you understanding. Any questions here? Can we move on from this one? Well, also, you have to understand that for live sessions, when you comment now, I'll actually see, I mean, on YouTube, for your live sessions, if you comment now, I'll have to wait, I think, 3 seconds or 5 seconds to actually see the comment that you posted. And then by the time I respond to your comment, you'll feel like it's appearing a bit later. Something like that. Like, you feel like I'm taking long to respond, whereas I just saw the comment 5 seconds later. Okay, but any questions here? Any questions here? Or we can move on to other 3 things. We sorted, right? All right, let's move on. The amount of mistakes I'm making tonight. I'm tired. Yes, Tapio, we leave it as k squared. It's no longer solvable from here because also the question said write these things in terms of k. Write in terms of k. How did we move from sine 41 to sine 49? We didn't move from sine 41 to 49. We moved from sine 41 to cos 49 because these are what we call cofunctions. So we shouldn't simplify. There is no simplifying further from here. This is fully simplified. This is fully simplified, Sabio. All right. You see how I prefer this chat now on YouTube? It's unlike the TikTok chat. By now, people would be talking about life science, physical science, technology, isiZulu, things like that. It becomes a mess. This is proper. And I think YouTube also limits you how many times you can comment in a time frame, which is super. Okay, yeah. Next question. Next question, we're going to 5.3. So since we are done answering any questions relating to this, I think we can erase here because actually the reason I'm usually waiting is so that I can erase. All right. I need this space. So this is where people lose marks just here and there, here and there. This is where people lose marks there. This is a trig expression, sorry. The same way you see algebraic expressions. Like you should try to have the same logic somewhere around here. Just that here, the most important things are two. You must know how to co-function. You must know how to apply reduction. Very important for you to remember these things. Extremely important. All right. So let's do it. We'll take things step by step. In fact, let's do them here, right here. I have a tangent where they're using 180 minus x. You should know what. Okay. I feel like my mind is running across too many things. So here's what I want to say. If you see a number roaming around 90 or 270, roaming nearby, it means you must use cofunctions there. Nearby or exactly there, use cofunctions. Hardly a number will move around 0, so there's no use to this one actually. But if a number is roaming at 180 or at 360 or in any multiple of 360, like 720, you get what I'm saying? Things like that. If it roams around any multiple of 360 or 180, then you know that it's a reduction. So starting with this one here, I have the tangent of 180 minus x. Clearly, if it's 180, it's a reduction, right? So we keep the same function. We don't change the function. We just make it negative or positive. Now we are going to say, in this quadrant of 180 minus x, how is, let's put that thing here because we need it. Cast. Right? Yes, we were saying in this, oh, I need to write, my mind is jumping across things. I don't know what's happening. Let me draw a proper Cartesian plane with all the details there. All right? Usually in trig, we use this nice Cartesian plane that has these elements. Choose a different color here. We said this quadrant is called the 90 minus theta, or it's called the 360 plus theta. This one is called the 180 minus theta, or it's called the 90 degrees plus theta. This quadrant is called the 180 degrees plus theta, or it's called the 270 degrees minus theta. And then this one is called the 360 degrees minus theta, or it's called the 270 degrees plus theta. And then most importantly, we know that this quadrant is also called the negative theta quadrant. Right? So this Cartesian plane, it's super important whenever we are dealing with things like this. So now we are here, 180 minus theta. Just read it like that so that you can understand it. 180 minus theta, it's in this quadrant, this one. Which function is supposed to be positive in there? Definitely not the tangent. It's supposed to be the sine. So which means this tangent, where it's sitting, it's negative. We take that. Negative 10x. Are we good? And then afterwards, you have this situation, the cosine of a negative angle. Where is the negative angle in this quadrant? It's in quadrant 4. So negative theta is in quadrant 4. Which thing is supposed to be positive there? It's a cosine. So we already have a cosine here. It means a cosine where this angle is, it's positive. We do the same. I'm going to say positive cosine of x plus, right? Then we come to this one. Now, this one, what I need to understand is that I need to take this square and put it here, all the way outside here. It's not an error on the question paper. It's a strategy to answer this question. Okay, so I'm going to say now, inside squares, what do I need inside here? See this square? It's the one I wrote outside. I have a sine in this quadrant, the 360 minus x or theta. So again, there isn't 360, which means we are reducing. We are not changing the function. We are only changing the sign. So I'm going to say, definitely, this is quadrant 4. But in quadrant 4, only the cosine is positive, right? So, which means in this case, this sign that is in this quadrant, this sign is supposed to be negative there. So I'll say negative sine of x, and that square is sitting nicely there. All right. Then afterwards, I have this part here also. I'm going to say multiplied by And then here I see something different for the first time. I see a 90. A 90, we are not reducing, we are co-functioning. So since it's 90, I need to look at where is this quadrant, right? This is 90 minus x. 90 minus x is the first quadrant. Now, in the first quadrant, everything there is positive. No matter what it is, it's positive, right? So the co-function of this thing, it's a sine. So I'll say sine of x, and that sine of x is positive because it's in this quadrant, and this quadrant is positive. Now, moving downstairs to the denominator, I have the sine in this quadrant. Judging by the value, this is 180. 180 means we are reducing, right? So if we are reducing in this quadrant, this is quadrant 2. Quadrant 2, it's this one here. In quadrant 2, which part's supposed to be positive? The sine. So if I have the sine in quadrant 2, that sign will be positive. So I reduce it to a positive sign this way. Are we good? Now you see the nice annotations I have. The nice annotations I have now, I can carry them downwards. Okay? Before I carry them downwards, how Hello says I must repeat the sine 360 minus x. Sine 360 minus x. This item says, let me write it here. I'll just do it on the side. The square sine of 360 degrees minus x this way. Judging by the value that I have here, this must be reduced, right? So since it must be reduced, first of all, I want to rewrite this with this number being outside. Like this number here, I'm taking it all the way outside. You're allowed to do that with 3, right? Now I only deal with what's inside, right? So I put that here, square. Inside, what do I have? Inside, I have a 360 minus an angle. 360 minus an angle, it's in quadrant 4. And in this quadrant, only the cosine is positive, which means the sign that I'm seeing in this quadrant, it's not supposed to be there. Now, when it's in there, it's negative. So I put a negative here. Negative sine of x. And that's how we got this value here with the square outside. All right. So taking this forward, I want to rewrite this entire nice equation down here. We do that. I have negative tan x multiplied by the cosine of x plus negative sine x squared multiplied by sine x. This is equals to the sine of x. Are we good? So and then afterwards, I'm like, hey, this thing is tricky here. Because of usually in these situations, I have a binomial. And I want to highlight these binomials with different colors so you can see it's a binomial. These two items together and these two items together, separated by a plus in between. So I have two terms separated by a plus. So now what should happen? Usually this denominator down here, this denominator must be able to cancel out with something up there. But it's not looking fancy now because here I don't have a sign. Here there is a sign I can take out. Here I don't have a sign that I can take out as a common factor, right? So let me sort some things out and see if my mind will pick up something as we go. Like this is me thinking like you in the exam, right? So you're going to say, okay, if I say here the tangent of x, this is negative by the way, multiplied by the cosine of x. This should I should be able to remove these brackets. So when I remove those brackets, it's like I have a negative sine of x multiplied by a negative sine of x multiplied by this item here, this one here, which is the sine of x all over sine x. Bear in mind, I still have, what is this? 2 terms, all right? And then I'm trying to simplify it using the long way, like I'm thinking as I'm doing it, right? So I have a negative times a negative, which is a positive, times a positive, it's a positive. I have sine x, sine x, sine x 3 times. What does that do? It gives me a cubic sine x all over sine x. And what am I seeing now? I'm seeing that, okay, in this situation, still nothing cancels out. You can break the fraction that each of them have their own denominator. Maybe something will work out for you. But fundamentally, what should pick your brain right now is this tangent here. Remember, tangent is a combination of 2 functions. Now, when it's like that, I can just rewrite the tangent as a combination of 2 functions. How do I do that? Tangent, it's the same as the sine of x over the cosine of x. That's the tangent. Let me highlight it the same so that you see it. Right. 10x is equals to whatever that I've highlighted green there. Right? So I'm multiplying this with the cosine of x plus the cubic sine of x. All this over the sine of x. All right. So what do I see? I see whole number cos x. I see denominator cos x. They cancel out. I'm left with what? I'm left with the negative sine of x plus the cubic sine of x all over sine x. Bear in mind, these are not like terms. The numerator does not have like terms. Right? It does not have like terms because the other sign has an exponent of 1. The other sign has an exponent of 3. Wait, what is happening here? Hey, halftime, they're beating Arsenal. Whoa, you guys are missing out because of maths. All right. And then afterwards, what do we have? We can take out a common factor now. A common factor is sine x. So I take out sine x from this situation. I take out sine x here. I'll take out sine x here. All right. When I take out sine x here, I'll be left with what? Negative 1. So I write that. Take out sine x. I'm left with negative 1 here from this situation. Plus, here, how many sine x's do I have? I have 3 sine x's. So if I take out 1 sine x, I'll be left with 2 sine x's. So I put that here. Square x. All this over sine x. All right. So this cancels that. I no longer have a denominator, which is what I wanted all along. Now I have negative 1 plus sine squared x. Now, here I want you to realize something that, no, man, this thing looks like something we know. Negative 1 plus sine squared x. No, this definitely looks like something we know. And then in situations like this, like the examiner will penalize you for not seeing it, right? I'm like, let's take out a common factor. We take out a common factor of negative 1. Or you can just say you are taking out a negative as a common factor, not to confuse you. It means this 1 now becomes positive, and the sign becomes negative. All right, and somewhere up there we did something like this. I think we probably erased it. Yeah, we probably erased it. We did something similar to this, whereby we said this thing here, it's an identity, and okay, let's just write it. Cos squared a plus sine squared a is equals to 1. And if I transpose sine to the other side, I'm going to have cos squared a being equals to 1 minus sine squared a, like this here. Right? So I have that kind of a situation here. this bracket looks like this part. So I should replace it with this situation here. And I'm going to say this thing here inside the bracket, it's similar to cos squared A. So I keep the negative outside and I replace that thing with cos squared A. Let's highlight it so you can see which part did we replace. Right? And then it ends there. There's no simplifying it further from here. Let's remove this. Any questions about this? Anything that you're not clear of? Yes, you can use X instead of A. That was just a thinking process. No, you can use X instead of A. I'm guessing you guys are sorted here, right? So we can move on to the next question. And this one, most definitely, their marks are so collectible, and I'll show you what I mean by that. I'll show you. So no questions about this one here, right? We can move on and deal with more things. All right. Right. Let's see. Let's erase this. I think it's actually nice. It's not that bad. I don't think I want to remove that Cartesian plane. Also, those stories, they are nice. Let's not remove them. Let's remove up until here. Yeah, great. So now we have to simplify this, right? There are a few things that here they expect you to see. So let's hope we see them. Let's hope so. First of all, we want to start by rewriting things. They say do this without a calculator. When they say without a calculator, they don't really mean it like that. They're saying that do not give us an answer in terms of decimals. You can give us an answer anyhow, but not as a decimal. Can be fractions, can be whole numbers, can be surds, but not decimals, right? So now we still need this thing here. As long as you're doing trig, you'll always need this diagram and the small information about how to use cofunctions and reduction. So here I have the sign of a negative angle. That's very important. It's a very important piece of information because they gave you a negative angle. It doesn't matter what is the angle. It's a negative angle, right? And 15 is not a special angle. So it's not different from the sign of X according to how we treat it, right? So the sign of a negative angle. A negative angle is in the fourth quadrant. And in the fourth quadrant, only the cosine can be positive in there. If it's anything else, we are saying it's negative. So let's write it down here. This is the same as the negative sine of 15 degrees. Are we good? Then I go to the cosine of 75. Now I want to see that, okay, what is the relationship between 75 and anything else? Because I cannot have a 15 and a 75. It's a lot of work, right? So I'm like 75, I'm like 15. 0, carry 1, 9, 90. So I'm like, okay, this thing of 90, it's actually using cofunctions. Because of any number that works with anything closer to 90, it's cofunctions. So which means this, I can cofunction it, right? Let's do that. Let's cofunction this one. So this, what is the cofunction of a cos? It's a sine. The complementary angle of 75, we just saw it now, it's 15. Do you see what we are doing there? We are dismantling this thing. So now that I can see that all the 75s can turn into 15s. If I see a 75, put a 15 there, right? But then here's the tricky part. When I have a tangent of 75, I cannot co-function this into a 15. I need to work around this, right? So I'm like, all right, since this is a problem, let's rewrite this. Let's find another way to rewrite this thing. We know that every time we have Tapi was saying, so shouldn't you make the 15 a 75? Whichever way, it goes both ways. You can turn the 15 into a 75, right? Okay, yeah, back to this one. I was saying that for the tangent of 75, because it's a tangent, I can rewrite this thing in terms of sine. This is the sine of 75 over the cosine of 75. So I put that here. Sine 75 over cos 75. Right? That's for the tangent. Multiplied by cos 75. We already spoke about the issue of cos 75 here. We said cos 75, it's sine 15. So I'm writing this as sine 15. Afterwards, I have the cos of 165. Now, bear in mind, 165, it's not really that close to 90, right? Let me see. Oh, we can get it there. Because this thing here, cos 165, is the same as cos of 90 degrees plus 75 degrees. Boom. Right? So which means cos 165, you're going to say this is the cosine of 90 degrees plus 75. And then we'll get to this. We'll get back to this. Now we can rewrite the whole thing that we have here. I have negative sine 15 multiplied by the sine of 15. Could have just added those together, plus sine 75 over cos 75, and the sine of 15 multiplied by the cosine of 90 plus 75. Let's start here. Let's chop the 3 from here. I have a negative multiplied by a positive. That is negative, right? And then I have a sine squared 15. I have a sine 15 and sine 15, that's sine squared 15. Right. In fact, let me write it this way, just for in case. I don't know. Maybe I might need to cancel things out soon. I don't know. Let's just keep it this way for now. And afterwards, I have a sine 75. Sine 75. If a cos 75 is a sine 75, then a sine... what am I saying? If a cos 75 is a sine 15, then a sine 75 is a cos 15. These are co-functions. Right? So same thing applies here. On this story here, I have the sine of 75. I take the sine and rewrite it in terms of cos, because of I can co-function this, right? We already know that. So this is cos 15 degrees, right? And then afterwards, the cos 75, we already spoke about the cos 75 multiple times. Here, a cos 75 is a sine 15. So I'm writing this as a sine of 15 degrees. Then here I have a sine of 15 degrees also. It's looking good. Multiplied by this situation here. Let me use a different highlighter because of this one, it's about to take us around. Right? So what's happening here? I have a 90 plus an angle. When I have a 90 plus an angle, it takes us back to the story here. 90 plus theta, it's the second quadrant whereby only the sine is positive here. So because I have a cosine in a 90 plus an angle quadrant, it means that cosine in here, it will be negative because it was supposed to be a sine, not a cosine. So I'll put that, I'll note. This cosine is negative, then afterwards I keep the 75. I co-functioned. No, I'm not saying it right. I'm saying this item here, this cosine, it's in this quadrant. And in this quadrant, only the sign is positive. So it means this cosine is negative in this quadrant. Put it there. This cosine is negative. But then because this is a quadrant of 90, remember what we are saying about 90s? Every time I have a 90 or a 270, I co-function the thing that I have. So the thing that I have, it's a cosine. Now that cosine, I'm turning it now into a what? Into a sine. This way. Right? And then I'll come back to it again because it still needs some changing. So what do I have here? I have a negative sine 15 and sine 15. Plus, here's what happens now. In this situation, I have a denominator sine 15. I have a whole number sine 15. They fall out. And then I'm left with the cosine of 15 multiplied by. Now, in this situation again, now I need to make some amendments. I see the sine of 75, and we already said here that the sine of 75 is the cos of 15. I'm taking it there. I co-function it like that. So this is the cos of 15. I don't even need those brackets anymore. Right? And then afterwards, what I'm realizing is that I have cos 15 multiplied by cos 15 in this case. And then here I have sine 15 multiplied by sine 15. What happens? This and this, it's negative sine squared 15 degrees. And then here I have a negative and a positive, which means they give me a negative. And then I have a cos 15 and a cos 15, which is a square cos of 15. Right. And then there is something here the examiner wants you to realize that in this situation, there's an identity that you're supposed to remember. So in respect to that identity, I'll take out a common factor. I'll be left with a positive square sine of 15. Here I'll be left with a positive square cosine of 15. Now, what does that identity say? It says these items, they are the same as 1, which means your answer is negative 1. All right, so there we go. That's how far 3 goes. Any questions now with this identity? Not identity, sorry. I'm too forward. It's a simplifying question. Any add-ons to this simplifying question? Any questions? You know why I prefer to have this live sessions on a Saturday? Is that if we touch base on something today, and then you feel like, this trick thing, it needs me to go back to the drawing board, you will have time. You will have tomorrow to catch up and ask questions. Guys, Arsenal equalized. He not bad at all. Okay, yeah. As I was saying, you will have time to not equalize. You'll have time to catch up on the things that you saw problematic today on a live session. Unlike having a live session exactly the day before you write, and afterwards we throw something there, then you realize that wait, you don't really understand this item of trig identities, trig onto this with the Cartesian plane and things like that. If we do it on the day before, it's becoming messed up. But then now, if we do it like on a Saturday and you're writing on a Monday, you have the whole of Sunday to catch up on the loopholes you think you had. Right? Can you explain cos 75 and sine 75? It's cofunctions. It's cofunctions. Cofunctions, basically, we are saying, let me use this part here. Cofunctions, basically, we are saying whenever you have the sine of 75 degrees, the cofunction of a sine, it's a cosine. And in terms of the angle, you choose the complementary angle that will land us at 90. So the complement of 75, it's 15 degrees because it gets us, because 15 and 75, it's 90, right? If I have the sine of 15 degrees, the cofunction of it will be what? The cofunction of a sine, it's a cosine. The complementary angle of 15, it's 75 degrees, right? Let's use other numbers. Let's use numbers that were not here on this question. Let's say you have the cosine of 35 degrees. What is the cofunction of it? The cofunction of it is that you take cosine, its cofunction, it's a sine. And the complementary angle of 35 is 55 degrees because 55 and 35, they add up to 90. I hope that makes sense. And then if also, another important thing, if maybe the angle already had a negative, it means the cofunction will also have a negative this way. So the negative sine of 35 will be the negative cosine, right? And then 35, its complementary angle is 55 degrees this way. Not too terrible, is it? We are left with exactly 1 hour. I don't want to keep on spending too much time on trig now. Oh, but I think we have more. Trig functions. Oh, lo, lo. Guys, you will do trig functions. And these things of, what are these? Cyclic quads, of course. Here we're talking about Euclid now. These things, they should be way more doable. There is this thing that I want to identify. The last question of Euclid, usually it's question 11. Question 11, or the last question of it, that's the monster of Euclid. If you're unable to get it, I would understand, but not all of it, of course. Like you see here, this thing is 25 marks. I wouldn't expect you to say the entirety of this 25 marks you were not able to get it. That's impossible, right? Even if you say this entire diagram alone, this one, you were unable to get it. Like all the 14 marks, we will have a problem. There should be something that is manageable there, right? Some things you're supposed to remember them. And then when it comes to proofs, I would suggest that you study proofs the day before the exam. There are a lot of proofs. And then if you know that, in fact, you have a lot to catch up on, just take a gamble. Just take a risk. We have a lot of proofs. Just study 3 proofs and hope that one of the 3 you studied, you do them. Because if you are blank in all the proofs, you can't understand them. And then afterwards, you force yourself to take all of them in. tomorrow by exam time, when you enter there, you leave them at the door. You are not going to enter with them. Just take it upon yourself that, you know what, I'm going to study the cosine proof. I'm going to study the sine proof. I'm going to study the one that says angle at center is equals to twice the angle at the circumference. Okay, boom. Then you take it like that. Or you say, okay, I'll study the proof that says a line drawn from center to the midpoint of a chord bisects the chord. And then boom, you take it like that. Like, because if you try to do all of them, they're going to mess you up so much. Okay, so now let's guys, I think 3 will be able to do. Okay, no, let's do it. Now let's do it. It's only one question. I was saying other things. It's only one question and it won't be too bad. And the one of drawing, obviously, you'll use a calculator to do that. I bet by now you know how to use a calculator to draw 3 graphs, right? This one you're not going to do, which means now this question that says use the graph to answer the following question, we are also not going to do it. So I'm only going to answer these 3 questions, then boom, we're done. Right? So, you want the whole day for Euclid? Of course you need the whole day for Euclid. Euclid is difficult. That everybody knows. It's an open secret. That trick is difficult. Okay, it says here, let's go about it. In this 10 minutes, I think we'll be done with this trick. The graph of f of x is this one. Right? It means this graph was shifted to the left. Shifted, I'll say shifted left. And how do you cram this? You look at major points, turning points, point of inflection, turning points, point of inflection, turning point, point of inflection, turning point, right? Remember those things. And then you see, what is this thing doing? So they say it moved 30 degrees. I mean, you have this, and you do see that it moved 30 degrees to the left, right? And they're saying you have this interval. This is what you're working with from here up until here, right? And it has been drawn in the diagram below. Okay, nice. What is the period of the graph? What is the period of the graph? The period of the graph, it's how many degrees it takes you to form one wave. Okay, like that one, I've been emphasizing it. How many degrees it takes you to form one wave. There are calculations to it, but if you actually understand the basics, you'll be able to do it. Okay, let me quickly get to it. When you have a cosine graph, it's like a sine graph. It goes, let me do this. A cosine graph goes on and on and on and on and on and on about this. For you to measure a wave, you can measure a wave from 2 points that are at the same place. You can say a wave starts here, it ends here. Whether it's cosine or it's sine, right? A wave starts and ends at the same place. You can also say that a wave starts here and it ends here, because boom, that's a wave, right? You can also say a wave starts here and it ends here, because boom, that's a wave. That's a full cycle of that thing, right? So that's one thing you're supposed to remember for these things. So let's go about it. I can see that, okay, here I have point of inflection, most definitely. Now, if I go all the way, to reduce this, oops, let's use the red for once. Okay, I don't know colors. If I go all the way like this, boom, up until here, we can all agree that this is half a wave. This is half a wave. That's all I need. I don't need for them to draw for me the entire cosine function with 3 waves and things like that for me to count how many degrees it takes me to form one wave. No, I only need this. Then we know, right? Now, let's make calculations from here to here. From this point to this point, it's taking us 120 degrees. How do we know this? Because here it's 0, here it's negative 120. So definitely from here to here, it's 120 degrees. And then from here up until here, it's taking us 60 degrees. Because you can see from 0 to 60, right? So clearly, for me to actually get half a wave, it takes me how much? It takes me the 120 and the 60, which is how much? 180 degrees. That's half a wave. Now, a period says how many degrees? It's a full wave. So if this is half a wave, it means now a full wave will take me 360 degrees. Boom. Right? There we go. So I'll just apply that logic there. I'm going to say my period is equals to 360 degrees because my wave took me 180 degrees. There we go. 1 mark for that. 1 mark because once you get into the exam, when you do it without explaining it to anyone, it will take you 1 minute. Then afterwards it says, write down the range of this graph here. Bear in mind, this graph does not exist there. That graph does not exist. So, which means whatever that we are working with, it doesn't exist yet. We need to put it into existence. Okay, how do we go about that? For us to go about that, we need to make the relevant substitutions the way we need to. And bear in mind, they only want the range, which means you only get marks for the range. Hence, you see the 2 marks. Graph interpretations are sneaky like that. But you only get marks for the range. Now, I want you to understand this. Since this is 2 marks, I'm going to zoom in. They're saying f of x, whatever f of x is, you must add 60 degrees to that, boom, boom, boom. Bear in mind that this part represents the horizontal shift. Once they add a degrees or anything, they are moving the graph left or right. That's what they're doing. But when we are talking about the range, we want to talk about up or down. Most definitely, right? It's a tricky one. So basically, these changes that are happening here, they don't concern us. Whether the graph is moving, how many waves to the left, how many to the right, it doesn't do anything to this graph to what is the highest point and what is the lowest point. Whether we move it to the left how many times or to the right how many times, it doesn't affect what's the highest point or the lowest point. The highest point will stay as the highest point, the lowest will stay as the lowest point. So the things that affect that, it's this part here. It's the vertical shift. This is what I'm concerned about, right? So I need to bear in mind, I'm making a vertical shift change to the main graph. That's all that I need to know. Then I go to the main graph. I look at it. This was the highest point. What was the new change? It was a +1. So it means this highest point will be here. That's all I need to know. Then I go to the lowest point. It means this lowest point will be 1 unit up here. Again, that's all we needed to know. Then we can make the range about it. That this is the maximum point for the entire graph. This is the minimum point for the entire graph. No matter how many waves we had. Then I can write the range there. You see that you didn't need to make all the substitutions. So you're going to say here that your range, y, is an element of, remember it does touch this value. It's an element of 0, and the highest point is 2, and it does touch 2. Boom. Others are writing this as an inequality. That's also acceptable. Use inclusive inequalities because we are touching those values. Boom. And there goes your thing. Your 2 marks. 1 mark for the values, 1 mark for the brackets, or 1 mark for the symbols. Easy as that. Okay, comments. No comments. Okay, we can go to the last question of this thing. The last question says, write the equation of h in the simplest form. So here's h, the one we were dodging. Let's do it. We know that f of x is equal to, we want to start there, right? Cos of x plus 30. And then, okay, h of x. We know that h of x, we must make the following changes. Where there is f, we must add 60 degrees on the horizontal shift. Let's zoom in a bit. Where there is x, we must add 60 degrees. So I'll go in there, cos x plus 30, and then we apply those changes. This change, plus 60. See how easy is that? Boom. And then the cos, the f graph didn't have a q value there, so it's fine. We just add this one that they wanted. Then we say plus 1. Boom. Then we write the final thing, the simplified thing. H of x is equals to the cosine of x plus 90 degrees plus 1. Now I want you to look at this, because the examiner now is tricking you. Because there's no way he'll give you something that has a cosine of 90 degrees. What else in the previous questions? In fact, even if it was not there in the previous questions, what else we know about cofunctions? Let's go back. In the previous question, we did cofunctions, and then we specifically said 90 plus theta is in the second quadrant, and only the sign is positive there. And we go back there, we cofunction this thing here at the end. We said only the sign is positive, so which means this thing here is supposed to be negative. And then 90 plus theta stays this way, plus 1. This is our h of x. Hence, he said the simplest form. He knew what he was doing. So if you were to stop here, you would get 1 mark there, and then another mark for simplifying it. Hey, wait, did I cofunction this? Sorry. What am I doing? The cofunction of a cosine, it's a sine. And the cosine in this quadrant, it's negative. Boom. Yeah. This is the way. Thank you, Tapio. I just realized that now. Thank you, Zumaza. I just realized that now that it's supposed to be a sine. Thank you, guys. Co-functioning things. Right, and afterwards, once they say plot the graph on the grid provided, guys, just use a calculator there. I think we've had multiple videos on how to use a calculator to plot cosine graph, even all 3 graphs, right? And afterwards, you come to this life skills questions here. Boom, you win. And then f having a minimum value, where does it happen? You know that it happens at the turning point. Boom. All right. So we have 50 minutes left. Still feeling energetic. Let's see how Arsenal is doing. I want these guys to lose. Come on. Hey, Arsenal. Yes, yes. How did they equalize? All right. Moving on to the next question. What is this? This is still trig in 2D, but guys, I'm done. I've been doing trig. By now, you would know how to do trig things, right? So let's move on with it. Euclid. Let's hear what it says. If it's super doable, we'll skip it. Yes, we all do, Tapio. We all do. Question 9, it says in the diagram, ABCD, it's a cyclic quadrilateral. Boom. A very important statement. Super important. What am I doing? Cyclic quadrilateral. O is the center. It's very important that they tell us that O is the center. Use the diagram to prove a theorem that states that opposite angles of a cyclic quad add up to boom, boom, boom. Guys, I'm not going to do oh my God. What's happening to Arsenal this year? These guys, they want to take the league. Okay, sorry, guys. Now I'll focus. All proof questions. I won't do proof questions. So just go cram those things, guys, and see how you do. Right. I want us to get to questions that actually need you to apply uh, Euclid concepts, right? Circle geometry concepts. All right. So let's go about it. 9.2, it says, let's read the statement. Guys. In the diagram, O is the center of a circle, right? With a reflex angle of 230. Here we go, right? And then PQR, and S are points on the circumference of a circle with chord SR. I don't know if this thing is chord. I know I've been teaching for years. I don't know if this thing is chord or chord. SR is a chord, right? Extended to a point T. There we see it. QRT is 85. We do see that. OPS is 20. All right. There we go. Here is something I wanted to extrapolate. What's happening is that once you're in grade 11 and grade 12, most especially grade 12, if a question has an error, like you remember earlier on, we had a question that has an error. If a question has an error, you are supposed to be credited marks. But then if you see that the question has an error and then you skip it, you don't get the free marks according to how things go in marking. Remember now for grade 12 also, when they mark for you, your papers will be marked externally. So if you see that the question has an error, you must write something, even if it's one line or whatever. You must write something so that you can be awarded the marks of that error. Otherwise, if you skip it, you don't get the free marks. All right, okay, let's move on. It says here, calculate the magnitude of the following angles. And usually they guide you, right? So they said angle S, 2 marks. Basically, I bet here they want statement and reason, 2 marks, right? So what do we know? Here's angle S. The other angles we have, it's this one, but definitely no relationship there. Exterior angle of a cyclic quad, it's actually equals to the opposite interior angle, so it doesn't relate to this. So basically here you want to use angle at center, right? So angle at center, it's this one, which is the 230, and 230, it's subtended by the same arc, like PR SST is being subtended by PR, right? They all should be subtended by the same thing, right? So I'm going to say angle S is equals to half of 230 degrees. And the reason for that, it says angle at center equals to 2 times angle at circumference. Right? So, very nice. So I'm going to say, therefore, angle S is equals to half of 230, 11.5, 115. Yes, 115. So, and then there we go, 2 marks, 1 mark for the statement, 1 mark for the reason, or maybe statement and reason, 1 mark, and then the answer, 1 mark, whichever way, right? So afterwards, the most important thing, write down the values there. It's very important because the answer you write as a statement, if you don't put it on a diagram, it won't really help you as much. It will be hard for you to make the connections. All right, next question. It says angle Q. Now look at Q. And then bear in mind, these questions, the way they guide each other. Look at the previous question to this. Use the theorem to prove, use the above diagram to prove a theorem which states that opposite angles of a cyclic quad add up to 180 degrees. Right? They prepared us with this. You know that after they asked a proof from you, the next question, there's no way you're not going to use this theorem. Okay, so there we go. I have angle S and angle Q. I can just work with that. I'll say angle Q. This is 9 point. Let's use a different color, in fact. I'll say angle Q is equals to 180 degrees minus 115. That is 65 degrees. Then I have to give a reason to that. I'm going to say opposite angles of a cyclic quad. You know, for some reason, after we dealt with trig, like trig from the beginning, it was very straining. Like you'd swear that, you know, Euclid, for some reason, it's like where you are breathing there. It's like, you know, the nice part, because of trig is intense. I would argue that trig is the most complicated, not impossible, complicated topic in a paper, because it's easy to make mistakes with the negatives there and the co-functions. Okay, let me move on. This is 65 degrees. Let's put it there. Right, so, and then afterwards I need to find P1. Where's P1? Boom, here. I think we already spoke about P1. There's no danger here. This is probably an Eastern Cape paper. So 9.3, 9.2.3. I want to erase. So I'm going to say P1 plus 20 degrees, it's equals to 85 degrees, right? P1 plus 20, it's equals to 85 degrees. And then the reason for that is that this is exterior angle, not angles, angle of a cyc quad. Then we just solve for this. P1 is equals to 65 degrees. Right? Yes, Zumasa, you're right. Euclid, it's actually very calm. It's a peaceful topic. All right, any questions here? We can move on. We are left with 40 minutes. Let's see how's the match going. Any questions? Arsenal. Hey. No questions, we can move on, right? So I can erase this, or in fact, I can just go to another page. So we have this diagram here. So usually, let me tell you what happens. The reason you see like this question here, I doubt if in Gauteng they ever do things like this, but this is very considerate. The reason you see this question, it's standing alone, only with one question that says calculate the the size of angle P. The reason things are like that, it's because they're trying to avoid you losing throughout, right? So you see here, they asked you 3 questions on one diagram. So, which means if actually understanding this diagram gives you a problem, you just know that you are losing three questions from it. Afterwards, they give you a brand new diagram, whereby now you have to, like a fresh start, like ask you a new question with a new diagram. Then you can now reanalyze this and work things out, right? So instead of putting all questions based on one diagram, now if you don't understand that diagram, all marks gone. That's very bad. They need to put in multiple diagrams. So it says in the diagram PQRS is a cyclic quadrilateral whereby QA intersects SR. Where's QA? QA intersects SR at a point A. Nice. SAQ is equals to 130. SAQ is 130. We see that. And AQR is 20. AQR is 20. Make sure that when you read the statement, it appears on the diagram. If it doesn't appear, write it down here on the diagram. Now, and then here it says, without, with giving, calculate given with reasons. Okay, calculate given reasons, the size of angle P. All right. So, most importantly, we need to highlight this statement whereby they said this is a cyclic quad. So use this. Boom. PQRS is a cyclic quad. It's very important, right? So we need to treat it. Of course, we can see that it's a cyclic quad, but okay, it's very important. Now they want us to find the angle, the size of angle P. Size of angle P. Now, usually in situations like this, whenever you are unsure of what to do, the best thing to attempt is that you need to solve out all the angles up until it lands where you want yours, basically. For example, right? For example, I can see here, like, this is you brainstorming now. Let me erase this. They want us to solve for P. So I'll put with a blue pen here, X on P. Yeah? So I'm trying to solve for anything I can solve, like anything that I can solve, and then see how it ties up to what they want. So I'm sitting here and I'm like, okay, how can I use this 20 degrees to solve for anything? Bear in mind, there are no alternating angles because there are no parallel lines. Okay, so I cannot make huge assumptions. So I'm like, okay, it's hard for me to use 20 to solve for anything. Okay, you move from number to number, then you go to this number here. You're like, okay, here I see that we have 30 degrees. I mean 130 degrees. What can I do with a 130? You're like, okay, I see that this 130 is sitting on a straight line. And then this is you brainstorming, right? You're like, okay, if this is 130, this means this can be 50 degrees because angles on a straight line, there must be 180 degrees. Boom, right? And you're like, okay, now that I have this, what else can I find with the 130? You don't know, right? You just know this entire part outside it's 180. This is 130. This is 50. All right. Then, okay, the next thing you're like, okay, this is in a triangle, QAR. It's in a triangle. It means you can find this angle, right? You have 50, you have 20. Together, they're 70. It means this angle it's like 110 degrees, right? Now that you have 110 degrees, what can you work with this angle? You're like, okay, this angle is opposite to this one, which actually gives us what we want. Then you go to the writing. Okay, so when you're stuck, just work out from angle to angle. See that this angle, what other angle can it give you? And then you see that you sort that out. Now let's put things in writing. Going back from the first thing. We said we are finding A1. A1 is equal to 180 degrees minus 130 degrees. Now the reason for this one is long. Adjacent angles on a straight line. Right? Therefore, it means A1 is equals to 50 degrees. This is 130, by the way, in case it's not really visible. Here is 130, right? And then you write it down. Then afterwards, you solve for R. You're going to say angle R is equals to 180 degrees minus 50 degrees minus 20 degrees. This is, how do you put this? Angles in a triangle. This is the shortest reason that I know, and it ends marks. Or you can say interior angles of a triangle. That is still okay. But angles of a triangle is also good. Right? So our R will be equals to, we said how much is this? 110. Yeah, 110 degrees. Right, so you put 110 degrees there. Like Euclid, it's very nice. Like you're working with something that you see. Now we go to this one. I'm going to say angle P, it's equals to 180 degrees minus 110 degrees. Our reason it's opposite angles of a cyc quad. Therefore, angle P is equals to 70 degrees. Boom, there we go. Not too terrible. Kahelo says it was easier than I thought. That's true. It's so doable. It's not too, it's not really that bad. It's doable. Right? To the next question. But don't look at an Eastern Cape paper and be like, hey, things are nice. Go to the Gauteng papers. Those ones, hey, those ones are the real ones. Guys, I'm not okay. Like a few minutes ago, Arsenal was losing. Now they're winning. This is the long way. Yes, Giza. Yes, Giza. This is the long way. I'm a person with long methods, so unfortunately, I'm sorry for that. Question 10. Question 10, remember, it's like the last question, but it's divided into two, like this one and this one. So we'll see. Usually, the first two questions of Euclid, they are very smooth, but the last ones, especially the last one, it's something else. But let's not have bad. It's not bad energy though. It's studying. Studying will teach you how a question paper is like. You would know what to expect where. Right. So question 10, it says, let me zoom in so that you can see, because I know that you might not be able to see this proper. It says in the diagram, O is the center, right? And then APB of circle APB, yeah, we see that. PB is extended to C, we see that. And then it says AC is drawn. PN is a tangent. To a circle at P, right? OS intersects AP perpendicularly. Where is it? OC, not OS. OC intersects AP perpendicularly at point O. Okay. P2 is 37. Where is it? Here. All right. Everything appears. Right. And then afterwards, we go to the next part. 10.1.1, determine given reasons the size of O1. O1. Whoa. Okay, let's see O1. Let's highlight it. Here is O1. Right? That is O1. So, number one, they never said anything about parallel lines. So, in which it will be tough for me to assume things like this. Like, they never said anything about parallel lines. So, I cannot assume things like this, right? I cannot. So, it's tough. Now, what I want to do now is that there's a statement that I'm sure I have skipped. And then that statement, it's so important. I was supposed to highlight it. This one here. It's very important that when they tell you that something is a tangent, you remember to keep it. But hey, this is a tangent. It's very important. So, with that now, this thing tells me that if this is a tangent, then I can make this angle 90 degrees. Now, when that angle is 90 degrees, it can make these lines to be parallel. Right? And then when those lines are parallel, I can have, what can I do with parallel lines here? What can I do with parallel lines? A1 plus A2, it's supposed to be equals to 37. A1 plus A2, it's supposed to be equals to 37. Let me see. A1 plus A2 supposed to be equals to 37. What would be the reason for that? What would be the reason for A1 plus A2 to be equals to 37? I just know, oh, no, only A1 is equals to 37. Only A1 is equals to 37 because of, if this is a tangent, like they said, now that I'm seeing it, if this is a tangent, this angle here will be equals to the opposite interior angle. The opposite interior angle will be this one. Right? And if that's the opposite interior angle, we also know that this angle is 90 degrees. I think I'm taking a long way around it. And then this angle, we are going to find it afterwards. Then after we find this angle, then we are going to say, no. In fact, here's an easier way. Once I find this angle, it relates to this angle. Yeah. So I'm saying this angle is equals to this angle. And then after that, this angle here relates with O1 because they are subtended by the same chord. And that chord, it's this one here. So the chord PB, it subtends O1 and it also subtends this angle there. Right? So which means this angle here will be twice the angle at the circumference because they are subtended by the same chord. That was a nice one. That was a nice one. Let's put it in writing. So we said P2 is equals to A1. The reason for this is what? It's the tangent and the chord. Yeah, 10 chord or contact. No, it's 10 chord. 10 chord theorem, yes. I remember now. Right? Therefore, it means A1 is equals to 37 degrees. All right. And then afterwards, we are saying that O1 is equals to 2 times A1. Our reason is angle at center equals to 2 times angle at circumference. This way. Therefore, O1 is equals to whatever A1 is. A1 was 37, so it's 37 times 2. 37 times 2, that is 74 degrees. Boom. Hey, it's worth 4 marks, this one. It was not playing. This one is worth 4 marks. It was not playing. All right, so let's put things. Again, it's important to use a pencil, not a pen, so that you can be able to erase and write only the important information. 37 degrees, 74 degrees. There we go. And it says prove that OACB is a cyclic quad. Now we need to highlight that OACB. Let's use a different color. O A C B. Perfect. OACB. We must prove that OACB is a cyclic quad. So with this one, again, we have to throw angles around and see where we end with each and every angle there. Right? So, Let me see if I can prove that, if it will be possible. If I can prove that this angle, since I have a value there, let me write it down. Okay, I don't need to write it down. If I can prove that maybe this angle, it's equals to this angle, then that can work for me as a cyclic. Oh, and I think I can already see it. Yeah, if I can prove that, or if I can prove that opposite angles are equal like this, I mean, they add up to 180, but that is far-fetched because I don't know this, I don't know this, I don't know this. So that is far-fetched. But here in this situation, this one can work out. What can work out is that I only need to prove that this angle is 90 degrees, right? And then if this angle is 90 degrees and this one is 90 degrees, these are angles in the same segment, right? So I work with that. Now, let's do that. How do I prove that B1 is equals to 90 degrees? Now, this is very interesting. How do you prove that B1 is 90? Anyone? How do we prove B1 is 90? B1 being 90, anyone? All right, I see you guys don't see it. What happens is that I have, let me use this pointer here. I have this diameter here. Since this is a, what is this thing? What is this thing? It's a straight line. I have this diameter here. They told me that AP is a straight line, did they? PB is extended to, I don't see it. Oh yeah, they did say that this is drawn perpendicular to this line, which means this line is a straight line. Yes, perfect. So I have this diameter here. Having a diameter, Renoko is saying, isn't the cyclic quad one that all corners touch the circumference of a circle? Yes, Renoko. A cyclic quad, it is exactly that, except the one that they gave us, this one here, OACB. You see, C is not touching a corner of any circle. So we are imagining that this is a cyclic quad. So we want to prove that we can actually draw a circle around this shape here, right? That's what it's about. But a cyclic quad also uses theorem 4 inside, the one that says angles in the same segment. And that's what I want to use now to prove this thing, right? So to do that, I'm using this diameter. And one thing I know about a theorem of a diameter is that a diameter will subtend 90 degrees, right? And where is that 90 degrees? The 90 degrees will be this angle here. So this angle is subtended by this diameter here, right? So when it's like that now, I'm going to say the angle B2 and B3 angle in a semicircle, right? I said that. And then, which means now B1 will be equals to 180 degrees minus B2 plus B3. I need to put angle caps here. Are we good? So now, why is that so? Why is B1 equals to 180 minus this? These are angles on a straight line. All right. And then what did I say? I said B1, B2 and B3 is equal to 90 degrees, which means this situation here also is equal to 90, right? Which makes my B1 now to be 90 degrees. And what do you know? That's what I actually wanted, for B1 to be 90 degrees. So that is equals to O3. And I'm going to say, therefore, B1 is equal to O3, and they are both equal to 90 degrees. Angles in the same segment. If you forgot angles in the same segment, this is a butterfly property there in circle geometry. That these angles, they're in the same segment. If they're in the same segment, then this is a cyclic quad. Right? So that's what we're proving here, that this is 90 and this is 90. Therefore, the shape we are seeing there, it's a cyclic quad. Not too terrible, right? So we need to make a conclusion. Therefore, how did I write it? OACB is a cyclic quad. Boom. There we go. And then this one is actually the path I wanted to take. The next question. This is the path I wanted to take earlier on, trying to solve for things. But then for some reason, I abandoned the path. I don't know what happened. But whereby we get to prove, let me use a different highlighter. We want to prove that this line is parallel to this line. I actually wanted to take this path at some point. So let's say maybe, oh yes. Oh, not bad. Not bad. Not bad. Hi. Hey, this guy's the been winning. Okay, guys, let's focus, man. OC. I want to prove that OC is parallel to PN, right? That's what I want. All right. So now I actually took this path earlier on, right? And then let's say in question 1, when you were solving for this, you actually did prove that OC is equals to PN. Now, what are you supposed to do on this part? Right? Because of this part, it's 3 marks. You cannot say OC is equals to PN proven in 10.1.1. No. You need to go to this thing, whatever you did to prove OC being parallel to PN, do it again here. Because with this marks, you cannot afford to just write one statement and move on. I hope I'm good there. Right? So now, what did we say about proving that these two lines are parallel? We were saying some nice things there. I think we used the thing that this part is a tangent when I said I forgot to highlight that this is a tangent. So that is that. We need to remember that this is a tangent, and a tangent will always be perpendicular to the radius. And I said tan coded. Okay, yeah. The tangent will always be perpendicular to the radius. Radius tangent are perpendicular. So we do that. Then we prove parallel lines. Easy as that. So I'm going to say PN is perpendicular to OP. Write my reason. Tan radius or radius tangent. You don't write it this way. You say tangent perpendicular to radius. That's how the reason of the theorem goes like. And then afterwards, you're going to say, therefore, right, this angle plus this angle will be equal to 90 degrees. Therefore, P1 plus P2 is equal to 90 degrees. You see that? And then you'll say, therefore, P1 plus P2 is equal to 90 degrees. And this is also equals to O3. And then afterwards, you write the reason there, corresponding angles. These are corresponding angles, all right? Because they form an F shape here. Corresponding angles. I hope that makes sense. Right? And then so if these are corresponding angles, then it means these lines are parallel. You're going to say therefore OC is parallel to PN. I don't think this one was too terrible, was it? Any questions here? Any questions on this one? We are only left with like 13 minutes. But also we are left with one question. But hey, that one question will kill. I don't think we'll be able to do all of it. Because we'll run out of time. And yo guys, I'm tired. All right, we can move on, right? Okay, let's move on. I have this one here. This is a very interesting question. It says let's zoom in for the statement. Now, Tapio, we can't end here. The bell will ring at 10, Chief. The bell will dismiss us. So, in the diagram, PAT is a common tangent. So here's PAT, as we can all see that. PAT is a common tangent, right? Of the smaller circle and the bigger circle at A, right? And then it says AMB is the diameter of the larger circle with M on the circumference of the smaller circle. AMB diameter and M is on the circumference of a smaller circle. They didn't say AM is the diameter of the smaller circle. That's concerning. Okay. Let me highlight this statement. It's very important. And then they're saying ASC and BC are chords of larger circle and MS chord of a smaller circle. Let's see. Chord of a larger circle, chord of a smaller circle. Right? M is the center of the larger circle. Okay, we see that. And then they're saying it is also given that the length of AM is P units. AM is P. Let's put that in writing. And they're saying the length, okay, AS is P minus 1. AS, P minus 1. And then BC is 6 units. 6 units. Now, the first question here says, name given reasons 3 angles equal to 90 degrees. How? Okay, the first one we will see, of course, it's this one. Angle subtended by a diameter. All right. Then we have to move on to the next part. The next part will obviously be what? Boom, boom, boom. Come on, come on, come on. It's this one. The reason for this will be, someone said P3. Let me see, where's P3? P3. There's no P3. P is here. But I get what you wanted to say. It's A3. Yes, it's A3. Right? A3, and our reason for that, it's tan chord. Oh, you have to say what made A3 to be 90. So you're going to say A3, it's equals to angle C, right? A3, it's equals to angle C, and it's equals to 90 degrees. Turncott theorem. If you ever see yourself writing an exam and you haven't used this reason, Turncott theorem, just know Euclid gave you a problem. All right, then afterwards we have this angle here, same story. So we're going to say S1 is equals to angle A3, which makes S1 90 degrees. And our reason is that this is a Turncott theorem, right? Because this is a tangent to the chord of this smaller circle here. Right? So we found them. Let's put them in a more clean way. I'm erasing important detail there. This is P. This is P minus 1. This is 90. This is 90. There we go. Let's see, why did they make us do that? How does this help us to answer any other questions? Give a reason why MS is parallel to BC. I mean, that's obvious. Corresponding angles. I'm going to say because S1 is equals angle C, which is 90 degrees. Corresponding angles. Because they have corresponding angles, therefore these lines are parallel. But bear in mind, these people... is it okay for us to say angles in a semicircle for the last reason in question 1? It's not okay, because we don't know that AM, hear what you're saying, we don't know that AM is a diameter. They never said that. They just said AB is the diameter of the bigger circle. I even showed it here. AMB is the diameter of the larger circle, right? They didn't say that it's a diameter of a smaller circle. So we cannot use angle in a semicircle if we don't know that this is a diameter, making it a semicircle. And question number 2, ain't the reason for A3 tangent perpendicular to radius? That can also be the reason. That can also be the reason. All right. So, what was I saying? Oh, we're proving parallel lines, and we did prove parallel lines. And then, so every time they ask you a question, just know that that question guides you. So here they said prove that the lines are parallel, right? So now that we did, we have to come back to the diagram and show those symbols that these lines are parallel. All right. So now next thing, write down the ratio of AS over SC. What's AS? AS, oops, didn't suppose. Here it is, AS over SC. This is a very nice question. Like, this is a very beautiful question. I see it now. Because look, we just spoke about showing these symbols, right? They just directed us to these symbols right now. And then afterwards, we have a statement that I forgot to highlight here. It said, am I right? There's a statement here. M is the center of a larger circle. I knew I saw something here. Right? See why it's important for you to internalize the statements in the beginning. When they say M is the center of the larger circle, basically they are telling you that, hey, M is the midpoint of this diameter here, which means whatever this value is the same. And then now, I wish I can rotate this shape so that you can see it, but I can't. This thing, it's like a midpoint theorem. It's like this. But it's not really a midpoint theorem. It's the opposite, the converse of a midpoint. This is converse midpoint, this thing here. Right? So if this is converse midpoint says if ever, let me draw this thing here so I can explain it properly. When you have a shape that looks like this is converse midpoint. When you have a shape that looks like this is midpoint theorem. You need to remember those two situations. So now in this, we are getting a shape that is like this, which is a converse of a midpoint theorem. Now, a converse of a midpoint theorem says if ever you get a diagram that is like this, your conclusion must be that therefore this side and this side are equal. That's what your conclusion is supposed to be. Right? So I'm going to use those conclusions now here. I'm going to say I list the things. Remember this thing now, what's happening? It's 2 marks. So I just want to work with it because they say they want the ratio with the reason. My ratio is that AS is the same unit as SC, which is 1:1. But I need to prove that. Here's my long way around it. Let's put this here. My long way around it now says AM is equals to MB. This is given. Here's what I'm talking about. AM is equals to MB. You can say given, or you can say radii, because this is a radius and this is a radius. And then you can say MS not equal, but MS is parallel to BC. How do we know that? We just proved that. Proven. What am I talking about? This line is parallel to this line. We just proved it. All right. And then you can say, therefore, AS is equals to SC, your reason, converse midpoint theorem. So in terms of ratio, therefore, since AS is equals to SC, the ratio of AS to SC is 1:1 because they are of the same unit. Oh, this is so beautiful. This is so beautiful. Hope that makes sense. I know maybe when you go and check the memo, maybe they might say it in a different way, but that's what I can think of now. All right. And then afterwards, we have the next question. I think I have 1 minute left. You can do a lot with 1 minute, even 2 marks question. Right. So write down the length of MS with a reason. The length of MS with a reason. Where's MS? My pointer. Here it is. MS with a reason. Oh, this is a lot of, oh no, it's not a lot of work. MS according to midpoint theorem, right? It's half of this, right? So in fact, it won't even take us that long. So because we already spoke about midpoint theorem, MS is equals to half of BC. And this is still converse of midpoint theorem. How do you know you're using converse midpoint theorem? It's the shape. If the shape is like this, you are using converse of midpoint theorem. But if the shape is like this, you are using midpoint theorem. The most important thing is the shape, right? If the shape is this, your reasons are going to be converse midpoint. If your shape is like this, your reasons are going to be midpoint theorem, right? You can also use Pythag, yes. You can also use Pythag, yeah. Kauhelo, I think Coincidentally, I just responded to your question now, right? You use converse midpoint because of this. We already proved parallel lines. We know that these two sides are equal. So I know that this line now, it's half of this line based on my converse midpoint, right? So I can say, therefore, MS is equals to half of BC. How much is BC? BC is 6. I don't know where we get the 6, but yeah, half of 6. This is equals to 3. You see why it helps to write values on the diagram? Look at this. I don't remember when did I ever say this is 6, but I can see there's a 6 there. It means at some point I knew that this was a 6. Then I just write it there. 6 is given. Thank you, Zumaza. Thank you. All right. And then afterwards, we move on to is it the last question? Yes, the last question. And then we're done, right? The last question says, find the value of P. You see how they guided you. They didn't just start by saying in question 3, find the value of P. They made you find the value of MS first so that you know that the value of MS is 3. And now you can move around it and use your Pythag and find the value of MS, right? Let's do it. I hate leaving a question unattended like that. So we can say AM squared is equals to AS squared plus MS squared. And you're going to say Pythag. I think someone said it. And then our AM now, AM we said it's what? We said this is P. So P squared is equals to AS, which is P minus 1 all squared, plus MS, which is 3 squared. Right, and then I have P squared is equals to, I have to write this twice. Once you get to grade 12, you'll no longer need to write this twice. You should be able to just solve it in your head from this point to the bottom of it. So first terms, I have P squared, outer terms negative P, inner terms negative P, last terms plus 1. Right, and then you have P squared on the right, P squared on the left, they cancel out. You're left with 0 is equals to, this is negative 2P plus 1 plus 9. This is not Q, it's 9. What was I doing? Right, so your answer here, you have, I have to take this to the other side. That is 2P is equals to, these ones are like terms, that is 10. All right, then what do? Divide both sides by 2. Therefore, just right next to Manala's ARC logo, this is poetic. The end is right next to the logo. Boom. There we go. P is equals to 5. How beautiful is that? This is so beautiful. Right. Super beautiful. So at least we did the most of this paper. And then, yeah, this question was not bad at all. It was a beautiful question. So, guys, I don't know if YouTube saves lives, right? So if ever it's possible for me to save this live and post it, but it's embarrassing. It has a lot of mistakes, but no, come on, we'll post it with those mistakes, right? So I hope you guys are okay. I have to go and watch those Arsenal highlights. These people, they are blocking us from taking the lead. Guys, just continue studying, guys. Go and do everything properly. Yes, we are writing Monday. Best of luck, Kahela. Best of luck with that one. Please go and study, guys. Do Euclid. Do trick. Trick is very tricky. Just make sure that you do those things, right? And then so that we can be set. By the way, stats is 20 marks. I expect you to come out with, if you did bad, like give me 15 marks for stats. What do you think needs the most important? What do you think needs more time to study? Why do you think it's most important? It's trig. Trust me, it's trig. Because trig, you're talking about trig functions, trig in 2Ds on a Cartesian plane, trig in 2Ds like in triangles, not on a Cartesian plane. We're talking about trig equations. We're talking about general solutions, which we didn't do. This Eastern Cape paper, I don't know what's wrong with it. We're supposed to do general solutions. We are supposed to do factorizing, simplifying in trig, and all those things. Like, that's what we are supposed to do. Like, trig has a lot of meat and bones. You need to make sure that you get it right. That 50 marks from trig, if you can get us at least 40 if things didn't go right, I'll be happy. Right? So, trig and Euclid together, they are worth 100 marks. Analytical geometry and stats, they are worth 50 marks. That's how your 150 is created. Trig, Euclid, that's 100 marks together because it's 50-50. Analytical, it's 30, and the other one, stats, is 20. So, okay, guys. Thank you for attending, guys. Goodbye, guys. Enjoy your study. Tomorrow, just make sure you wake up and study heavily again. I'm just going to watch this match against Chelsea. I think it's going to lose to Wolves, right? And then all the best. Do I think you'll be able to finish the paper? It's tough to finish paper 2. Like, Euclid and geometry needs a lot of analyzing. Just answer the questions that are doable. Don't start with question 11. Like, come on. Question 11, it's the final boss of paper 2. I don't expect you to just start with the final boss, right? Just do things, the easy ones first. That's where you collect marks. And then, yeah, things will work out. If you don't finish the last question, that's okay with me. Use of the last question anyway, right? Especially for paper 2. Right? And then make sure you use your formula sheet. I'm sure for those volume and surface area things, they'll throw in some formulas here and there. And then just do that. I don't think it'll be too terrible. All right. Please make sure you study, guys. All the best. I'm signing out. Have to go and eat now. Yeah, it's been a session. So I hope you study well. Goodbye. And see you guys, I don't know, next year, because I'm done with you guys. Then I'll focus on the grade 10s. All the best.